welcome everybody. I appreciate y'all taking the time to be here today. We're going to take a look at utilizing, as Cassie said, utilizing reality capture data inside of your Autodesk package, your manufacturing solution, the product design and manufacturing collection. My name is Rusty Belcher. I'm one of the things I get a chance to do here at Imagine It is work with the reality capture team. I'm not out in the field scanning. They don't let me use the scanner very much. I have been out in the field. I've scanned a few things, and I'm going to show you some of the scans I've done today. But I focus more on utilizing the scans. Once you have a laser scan, how do you get it into your software? And then once it's in your software, what can you do with it? What processes can you utilize based on your scan to generate 3D models or 2D documentation of the 3D scan data? So I really do focus on using the data more than I do collecting the data. And that's what I want to focus on today. That's really what we want to focus on for the time that we're together. Just a few bullet points to start off as kind of a small agenda. We're gonna focus on Autodesk Recap today. Autodesk Recap is the point cloud solution that's inside of the product design and manufacturing collection. We'll take a look at that, and inside of that tool, we'll take a look at how do you orient your scans? How do you get the world to line up to your X, Y, Z coordinate system? How do you clean up the points? How do you, I don't need all the points. I just need a few of them in my CAD system. So how do I go about cleaning that stuff up? A lot of options for importing and exporting clouds. We'll focus on that a little bit. And then really we want to focus on using the scans in Inventor, possibly in AutoCAD as well, and even Navisworks. So we'll take a look at how those scans can be utilized in each of those tools. And if we get a chance, we might do a few modeling processes based on the scans as well. So I've taught Recap for quite a while. I've been using it for quite a while. And one of the things I talk about in all of my classes, in all of my seminars, is the fact that if you want to use point cloud data in Inventor or AutoCAD, you've got to take the point cloud data through Recap first. Now, I'm focusing on just the Autodesk solutions today. I know there are other tools out there that run on top of AutoCAD that handle point clouds. Possibly you know of one or two that might even do the same thing in Inventor, but if you are using just the core Autodesk tools, this is the workflow that's going to work for you. You're going to bring in your laser scans from whatever source you want into Recap, and then you're going to go from Recap either into Inventor or into AutoCAD. Now, I did mention Navisworks. Navisworks is a very mature tool. It's been around for quite a while, and it can read many different types of point cloud data. It can read ASCII data, Faro, Leica. Oh gosh, all the old translations that Recap can read, they can all go through as well. It also reads Recap data. So Navisworks is the catch-all. It's the digital mock-up of my environment. So it can read all kinds of 3D data, and point clouds are just one of the little, just one file type that Navisworks handles. It handles all the 3D models that you can throw at it as well. And hopefully we'll get a chance to look at some of that while we're together today. I wanted to frame our time together today based on a class that I have been teaching for the past year. About a year ago, we developed a class. Actually, it was right at a year ago. We developed a class for shipbuilders to look at Recap and how to bring point cloud data into their Autodesk software. It was actually kind of odd. Almost within a full week, we had two shipyards contact us directly, and both of them said the same thing. They have had teams out in the fields with 3D scanners, laser scanners, And they've been scanning away, and now these laser scans are coming in and they're landing on the desks of designers. And these designers, for the first time, are having to incorporate the laser scan data into their design processes. And they were kind of falling short. They'd spent so much time getting the right scanner, getting the right team in the field, that they hadn't focused on how do you utilize the data, where do you store it, how do you divide it up and get it into your CAD systems, and then once it's in the CAD systems, what can you do with it? So we developed a 2-day class. In this particular case, it was based on ship design, but you're going to see, hopefully today, we could have based this class on anything. If someone were doing substation design, we could absolutely do the same class with that. Or if somebody was doing, automotive design or facilities restructure like a factory layout or an upgrade in a factory facility, we could easily augment this little class just by changing the data sets out very quickly. So we have this class, and what you're going to see today is just a little 1-hour excerpt about what that class actually contains. If you're interested afterwards, if you're interested in maybe getting a class set up for your team to deal with your cloud data, let us know. Be glad we could customize that class to fit just about any kind of point clouds you can throw at us. So let's start off with recap. I mentioned before, you're going to have to go through recap. You're going to have to get used to it if you're going to use point clouds in your CAD system. So during our class, actually, recap's not a very large tool. It's not a very complex tool. Usually it takes me a couple of hours to go through recap and touch every single button in the software. Doesn't take long to, there's not that many buttons in it, not that many commands. So it doesn't take long to get familiar with it. And then we focus on how it fits into your current workflow. How am I going to take these scans and get them from the laser scanner through recap, all cleaned up, and into my CAD system? That's what we focus on. And then we basically do that over and over again for 2 days. We have a lot of clouds that we get a chance to use. It's not just ship compartments or whatever you work on. I've got some other scans that we can use as well. I'm going to jump into recap just for a minute, and I wanted to talk about this particular class that we did. I'm going to go back to my home view. We had these, the shipyards contacted us, and they wanted us, they go out and they scan compartments on board ship. They'll take the scanner into every single compartment that's going to be modified during a refit or and they'll scan every compartment that's going to be modified and basically pack that off and send it back to the shipyards. Well, we're really fortunate. I live in Hampton, Virginia, right across the river from Norfolk, Virginia. And in Norfolk, Virginia, we have a maritime museum. At that museum is the battleship Wisconsin. It's an Iowa-class battleship. And for this particular class, we actually took our scanners up on board the Wisconsin, and we scanned several compartments. We used those compartments as the basis of the classes that we were teaching. And I've got to tell you, if you've never seen an Iowa-class battleship, if you ever get a chance, you really want to look at it, and it's really, really impressive. This battleship is bigger than the entire maritime museum that it sits beside. It's amazing. But we got a chance to crawl all over the boat, take our scanners into different compartments, different types of compartments, and scan those things, and use those data sets as the basis of our class. I'll show you some of those in a minute. But we have other scans as well. I went out and scanned a jet airplane. I like machines, so I wanted to have a few large-scale machines that we could dissect and use in the class as well. Even things like an old pickup truck. I have a marina right near my house, and the owner of the marina has this amazing old 47 Ford pickup truck. And I was there scanning some stuff anyway, so I scanned the pickup truck, and the scans turned out really well. And these are just some of the data sets that we used in the class as examples of how to take CAD data or the point cloud data and how to get that stuff into our CAD systems. So you'll see some of these today throughout our little time together. I'll finish off by showing you one of the compartments on board the ship that we scanned. This is actually a scan that we focused on mostly during our class. Let me hop inside of it. I'm in recap here. So with recap, you can easily come in and look at the scans. These massive scans, you know, you're looking at about 18 gigs worth of data right now that's up on the screen. Recap handles that data really, really well, so we can view it. We can look inside of the pictures. The scanners they were taking pictures as well as while we were scanning. But we can also look at the 3D data. I can actually see the points, and now I can see right through the machine that's right beside me, or I can pan around and look at the compartment from anywhere. Shipbuilding is a really neat profession. When it comes to engineering, I think all the disciplines are represented when you're building a ship. Certainly, if I look above, ship designers deal with structural steel all the time. Tons of structural steel is exposed in this old battleship. HVAC ductwork, that's a huge discipline in shipbuilding. Machine installation, piping, electrical design, all of that stuff is represented inside of this single compartment. And the shipbuilders I was dealing with were coming from various departments, and their challenge through the classes were to come into this compartment and to take out maybe a wire run if you're an electrician, or to take out a pipe run if you're in the piping group, or an HVAC run if you're in the HVAC group. We want to take those things out of this compartment and get them into the CAD tool of your choice. And then in our class, we focused on basically setting up that file to take your first step in making a model. We didn't really finish the models, but we got them ready so that they could be the basis of our new model that we are about to create. So I'm going to show you really one of the main examples we use in the class, or another example. Let me go ahead and open up. I call this file the boat, so hold on just a minute. I mentioned the marina that's out behind my house. I drive by the marina quite often, and I have noticed for quite a while they have in dry storage this very large, it's actually a small ship or a large houseboat. It's a Florida Bay coaster. That's the name of the ship that you're looking at there. And for the class that I was developing, I asked the manager of the marina if I couldn't come out and scan that ship. He said, sure. So I set up, I think, about 18 or 19 scans of this particular ship, and I use it as the main exercise for teaching people recap, for focusing on just what recap does. If I zoom out, you'll see that when I set the scans up, I didn't just scan the boat, I got all of the landscape around the boat. Oh, the scanner, it just records it. You just set the scanner up and it records everything. So I got quite a bit of information in this scan that I do not need. I don't know how I would go about modeling trees, but I don't need to do that here. I want to model the boat. I think that's the focus of the project that I want to do here with you guys today. So recap, first off, it handles this cloud very easily. Again, this is probably about 15 gigs worth of data you're looking at right here. And it's nice and it moves fairly nicely easy on my screen. So just visualizing the cloud is one of the big benefits of recap. There's plenty of ways to navigate. You can fly, you can walk, you can navigate so many different ways, and we talk about all of those in the class. But you have to understand that we don't need to take all of these points over to Inventor or AutoCAD. We just want to take the points that are the boat, nothing else. So we're going to use recap to clean up this scan before we export it and send it over to Inventor. Now, there are a lot of ways to clean up a scan, and a lot of things you want to think about before you really go too far. So let's see if I can't. Let's talk about let's talk about the origin. Your CAD system, I think most of us are used to using CAD systems. I think we all know the XYZ coordinate system by heart now. Your UCS. Well, your UCS of the scan is actually set by the very first scan that was done in the project. So I happen to know this was the first scan I did. I'm going to hop in here. And when I set the scanner up, this is where I set it up. This is the first scan that day. It was over a year ago, a very cold day. Had been raining quite a bit. But this scan is the one that set the UCS for the entire project or the entire scan. Well, that's not going to be good. I need that coordinate system to be on the boat at a known position, and I need the x-axis to go fore and aft. I need the y-axis to go inboard, outboard, and the z-axis needs to go up. And recap can actually allow, one of the main tools is the reorientation of the cloud or being able to come in and set up your own coordinate system. Now I'm going to hop on the back of the boat here. You'll see these where I'm looking inside the pictures, these are called real views. So it's not the cloud. It's actually the 3D or the spherical picture that was taken by the scanner when it was sitting on the back deck of the boat here. Now, the center of the boat is right along the lines here of this door. This boat, once I scanned it, I started to do some research. I actually wanted to find some AutoCAD drawings of this boat. And I was fortunate enough to find out where they build these boats. And I called and I talked to the designer of the boat, and I asked him if I could get some drawings, and he was very glad to help me out. He actually gave me the drawings of the boat, and I know from the drawings of the boat that the doors are right on the center line. And right here at this deck is where I want the 0, point to be, right here. So in recap, we have a number of tools. Let me hop back into the point view here. We have a couple of tools, a number of tools. There's not a lot of buttons in recap. It doesn't take that long to go through all of them. But I can come here and there's an update origin, and we focus on this quite a bit in the class, setting up your origin. What I'm going to do is pick a point right here on the center line. I'm not going to sweat that. It's going to be pretty close. It's not going to be perfect, but that point will do. And then basically you read the instructions down here on the tooltip. It says click to update the location, enter to confirm, or tab to update the coordinate directions. So if I click the tab button, I can go through and set up Z and X. So Z, the upwards direction is usually, that's already set by the scanner. The scanners have internal tools that allow them to do a very good job of knowing which way up is, just like your cell phone. They have internal mechanisms that read up and down very, very accurately. So Z is usually pretty good. I'm just going to confirm that. I'll hit enter. And now it wants me to set up the X direction. Well, we select clusters of points to do that. Like this cluster of points over here to the side. If I select that, you see that the X direction is now going fore and aft. Or I wouldn't want to pick on the door because the door is a little bit open there. I don't know if you can see that. I might want to pick down here a little bit, but I think over here is a good cluster of points that we could use. Now, I've got my x-axis pointing aft. I want it to point forward, so I'm going to hit the Alt button. That flips it so the x-axis points forward. Once I have it set up the way I like it, I hit Enter. And now my UCS of the scan is in a known position, and I've defined which way the X, Y, and Z directions are set. I'll zoom out here and take a look at the boat. A couple of things, they start to become apparent, the view cube. If I look at the top view now, the scan will start lining up with the view cube much, much better than it was before. All right, so now I've got my coordinate system set. Now I want to look at cleaning up the cloud. I want to get rid of all the points that I don't need. So I just did the top view. Let me hop back into the top view for a minute. Now, if I zoom in, you'll notice that we're in perspective mode, almost like I'm a bird flying above the boat here. If I fly over top of this thing, you'll see that, you know, the top of the boat moves at a different speed than the bottom of the boat because of perspective. Well, I can actually go under the eyeball here and turn perspective mode off. That'll put me in orthographic mode. And this is what the drawing of the boat looks like. Let me pull the drawing up real quick. The designer of the boat, his name is Jay Benford. He's just a great guy. He worked with me putting this class together. He was wonderful. And the drawings that he sent me of the boat were old hand drawings he had done in the 70s. So I took his hand drawings, and being an AutoCAD, veteran, I put them into AutoCAD. I traced them, so I converted his hand drawings to DWG. So here is his original drawings. I just traced them. There's the boat. That shape of the boat is almost exactly now what I'm seeing inside of Recap. It's a pretty neat design of the boat. It's got a big salon, or it's got a multi-story houseboat built on top of a very, very functional large-scale workboat. It's so large that you can park your car on the front deck of the boat if you have a Jeep Wrangler or something like that. I saw this and I was a little skeptical that this crane could actually pick a Jeep up and set it on the deck. But sure enough, there are YouTube videos you can go out and watch people putting the Jeep on the deck. Actually pretty nice. But back in Recap, now that we're in orthographic mode, it's a little bit easier for me to make selections than it was if I was in perspective mode. During the class, we talk a lot about the selection tools. There's a number of them available. I'm just going to show you a couple. And if you've ever seen Recap before, you're pretty much familiar with this. It's a rectangular selection tool. So I can come in and basically I can clip the outside. Clip is not erase. Clip is just don't show it. Hide that for a while. So we just got rid of a lot of points. Well, we could get rid of even more. There's a planar selection tool. So we can teach you how to set up your plane selection tool. Basically here you just pick a bunch of points on the ground plane. Now this ground is grass and mud, so it's not going to be perfectly flat. So I'm going to maximize the thickness here. I'll hit Enter. And it selects all the points in that average plane that you see there. And I can hide those as well. Let me grab another rectangular selection. I'm just going to clean this up very, very roughly right here. I'm going to try to get rid of most of the ground there. We'll get rid of all this stuff up front. We also have a fence selection tool. So if you wanted to draw an odd-shaped polygon, you can delete stuff that way as well. So we teach quite a bit of, we teach in the class, we focus quite a bit on getting rid of the points that you don't need or hiding the points that you don't need. There we go. So real quickly, we've got the boat cleaned up the way we'd like it. We also focus on the idea of scan regions. Regions are like layers inside of AutoCAD. So, I can come in, for instance, and I have the upper part of the upper deck set up into a region. I can turn that off, just like a layer inside of AutoCAD. Or I could turn off the lower cabin, or I can expose the lower cabin so that you can actually see inside of the boat. We got a chance. We had limited access to the inside of the boat, but I got several scans of the inside of it available here, so you can actually see inside the boat, just like layers inside of AutoCAD. I can turn those things back on if I need to. So that's just, again, some of the things we focus on in the class is organizing the point cloud. Recap acts as a visualization tool. We focus in the class, we focus a lot about, generating videos or generating screenshots. There are options to do that. You can export imagery, or you can actually animate view states. Now, let me see if I'll open up this one right here. Here's a video similar to the video we generated in the class. Now, if y'all bear with me, I'm showing a video via WebEx, so it might look a little chunky on your side, but on my side, it's perfectly smooth. If you are the person that's, if this is your project and you're dealing with people who don't understand point clouds, they don't understand CAD software, being able to visualize your project is really important, and Recap can do that as well. So there you go. It just takes minutes to generate a movie like this. It does not take long at all to build a movie like you see here. Actually quite easy to do. And the movie can include the real world pictures as well, not just the points. So once you have the scan clean, we focus a lot on exporting it. When you go to export your scan, you got a couple of things to think about, a couple of file types that you have options for. You could export the project file as it is. All right. If typically I don't export and create new project files. That's an RCP. If the scan is good the way it is right now, you could use it as it is right now. Just insert the RCP into Inventor. But in the class, we focus on these little RCS files. Actually, I can make a brand new file that's just these points. It's a single standalone file that has just the points you see on the screen. It's much smaller than the original 15 or 18 gigs of data. It's about half a gig of data. So it's small enough to go into my data management systems and to become a document that I can then put properties on and I can lock down as the basis of a project that I'm working on. We can also export to PTS or E57 if you're going to other laser scan packages. But typically, I would export as an RCS file at this point. That's typically how I would work. Sometimes I will use the RCP, but most of the time I use an RCS file. Now, I've got this already done. I've already exported this out. Export takes about 2 or 3 minutes on this particular scan. But if you have a massive scan, it can take quite a while to export. So I'm going to minimize recap for a minute. I'm going to hop into Inventor. So the other half of our class is actually bringing in this clean scan into the CAD tool. Now I'm going to use Inventor first. I'll try to do this in AutoCAD as well if we have time, and hopefully Navisworks at the end of this. During the class, we talk a lot about workflows. Let me just pop into PowerPoint here for a minute. We talk about workflows and what's the best workflow that we would recommend for the customers we're working with. We were, again, in this class working with shipbuilders, but people doing substation design might be a little bit different. We talked, again, you can see the line refinement, and we'll get into the surface development here coming up. But also we focus a lot on reality versus CAD. And I will get a chance to talk more about that in the upcoming demonstration. So back in Inventor, I'm going to start a new file. So I'm going to go to File, New. And I want you to notice I've got a point cloud template. This is a template. I'm going to go ahead and start based on this. I've got the unit set up. Everything's ready to go. I've got my work planes already labeled. I've got axes that are showing already. And this is going to help me when I land the point cloud in the CAD environment. I'll be able to see how well it lines up to the X, Y, and Z axis. So in Inventor, you attach your point clouds on the Manage tab. Here I've got the chance to bring in an RCP or an RCS. Notice that that's all you can bring in. All right? Inventor only reads recap data. So here's my clean boat. We'll go ahead and bring this in. Comes in on my cursor. I'm going to click to drop it off. And in Inventor, if I want to drop this at 0, you have this option here, Insert at Origin. We'll click OK. So there's the cloud. And I can see the axis already in place, so I can start to judge how well I've got the boat aligned to my coordinate system. So looking vertically, that looks pretty good. I'm parallel. It's not perfect, but we'll fix that in a minute. But again, remember what I said. Usually up and down, you rely on the scanner to set that for you, so that's not really a big issue. So let's look at the top of the boat. Now I'm going to zoom in. This is where working with point clouds is so nice. I can actually see right through the boat. There's the point where the door was, where I clicked on the deck. And I can see the keel. I can actually see the keel all the way through the boat. And if I follow the keel, I can see that, you know, in recap I was pretty close, but I certainly wasn't perfect. Now perfection is something I'm never going to be able to attain because I'm dealing with reality. You know, once you build something as big as a boat, it is not ever going to be exactly perfect again. You know, I know with ships in the summertime, they get hot and they're bigger than their design spec. And in the winter, they shrink, they get cold. They're less than the design spec. Look at, you know, the walls in your office or maybe even in your house. You know those walls look great, but are they truly plumb? Are they truly flat? No, there's going to be imperfections in reality. And you have to come to grips with that if you're going to use or base a project on real-world data. But I can make this a little bit better. Inside of your CAD tools, there's always ways you can refine the alignment. And Inventor happens to, you right-click on the cloud and edit the attached data. And I know from just setting this up earlier that I'm a little bit off on the Z-axis, so I'm going to type in a value here. I'll click OK. Now, I could, you know, in reality, I might have to tweak this a little bit here and there, try multiple times. But usually the first 3 or 4 times, I could get that axis to go right down the center of the keel. So in recap, we get close to setting up the coordinate system, but in your CAD tool, you refine it and get it as close as you can. Is it ever going to be perfect? No, it's not. It cannot be perfect. Now, in the class, we take at least one step towards making a model. Now, you don't have to know Inventor in my classes. You really don't have to know AutoCAD. So these steps are really kind of primitive or very, very simple steps that you could take just so we could say, hey, does everyone understand we could start modeling at this point and start developing the design from the point cloud. In this particular case, one of the things I have this AutoCAD drawing that Jay Benford gave me. I would like to overlay the AutoCAD drawing on top of the ship. So in Inventor, oh gosh, you get the box crop tool. So I'm going to crop away or hide this half of the boat. And I'm going to overlay that AutoCAD drawing and see how well the reality scan lines up with the original CAD drawing, or the original hand drawing, let's say it that way. In Inventor, you have this wonderful tool called Import. You can import all kinds. Usually you import 3D data, but here I'm going to bring in 2D data. Here's the AutoCAD drawing. And in case you're wondering, in that AutoCAD drawing, I did take the time and move that file so it lines up with the coordinate system that I'm using. So that back deck right underneath of that door is where 0, 0 is in these AutoCAD drawings. Now, I already have my work plane set up, so I'm going to select the work plane, and I got to pick a point which is already visible. It's nice. So I'll click OK, and I'll bring in that AutoCAD drawing. So here is a hand-drawn version of this design that was created, I think, in the early 70s, laid on top of the cross-section of the reality capture scan. Now, it's not perfect. It's never going to be perfect, but it's pretty close. Amazingly close. And here's some of the things just in design terms that I really need. I needed to have the spacing the way the boat was developed. That's very key for, if I want to start the design again, I need the correct measurements that they started with. I'm not going to be too fussed that the windows are a little bit off. They are really, really close. And, remember, this was a hand drawing that somebody did prior to the fabrication of this boat. I don't know when this boat was fabricated. It might have changed something in the years since, but there you go. This would be a great place to start off my modeling process. This would be a great file to use as the basis of a model. Can you imagine having to model this boat from scratch? Just take a second. Maybe you're not a shipbuilder. I'm a shipbuilder by trade. I apprenticed at a shipyard, and I used to be a steel fitter, and I worked in the mold loft at Newport News Shipbuilding. So most of my war stories are shipbuilding related. But can you imagine, imagine modeling your pickup truck or the car out in front of your house? Where would you start? How could you start that project? Well, if you have reality capture, a scan of the object, that is the best place to start. Because I can get it set up, I can get it aligned to my CAD system, and now I know what I need to draw. And it could be as simple as making a trace along reality. That could begin the process of you starting your model or starting your 3D design. Now, let me see. I'm going to open up a file for you for a minute here. We'll talk about just one of the modeling steps we talk about in the class. There we go. I have this one set up a little bit closer to, I've already got a couple of the lines set up on it. Now, you might be saying to yourself, you know, this idea of tracing reality is kind of concerning to you. Yeah, it might be. I remember the first time I started tracing, you know, real-world data. I was amazed how how simple it could be. But you can make mistakes. You have to be careful about that. You know, it's never going to be exactly perfect. You have to make peace with that. But if you could trace a 3D object like a ship, you can trace any simple object. If you can model a ship, you can basically model anything. So I wanted to show you, you know, a difficult example here. So I'm going to start a sketch, and I am going to use this plane right here. You guys bear with me for a second. I'm going to reorient my design. I'm just used to the boat being this in this direction here. So it's this edge right here. I'm gonna slowly move my cursor around the edge. That's the edge I want to trace right there on the side of the ship. Now I'm going to grab a spline. I'm going to use the interpolation spline. That's just the one that I like for this. And you guys forgive me, I'm going to do this really quickly because we don't have a lot of time together today. But if I had plenty of time, I'd have a grid system laid out here, and I'd pay a little bit more attention to exactly where I'm snapping here. But I'm basically tracing this edge. Let's stay away from that line a little bit. There we go. Again, forgive me for just going through that pretty quickly. But there's the edge. It's really close to the edge that you see there. Going to finish that sketch. Now I want to sketch on the top plane. I want to look down at the boat. Now this particular line is really the outer edge of the hull. So I'm just going to carefully come through here and trace the outside edge of the hull. Again, kind of forgive me for doing this as quickly as I am. It is a spline, so I can activate the handles, and we can twist the spline and adjust it to suit. There we go. For what I'm doing, that's going to be pretty good. So if you can trace an object in 2 dimensions, you can always solve for the third. And that's where the 3D sketching tool comes in. And I know in our basics class and in our advanced class, we hardly ever talk about 3D sketching. But in my point cloud class, it comes up on the first day. I have this line and this line. There's a tool called intersection curve. And those 2 lines will generate the line that's on the shell right there. Let me see if I can make that a little bit better for you so you can see it. There we go. So we just generated this 3D line that follows the point cloud on the ship. If I were to move around, you can see that that line is really, really close to being right on the cloud. And if I had plenty of time, I could make it quite a bit better, much more accurate. But for a quick pass, that's not bad. When you talk about tracing clouds, you absolutely want to take a little bit closer look at that box crop tool. You know, for instance, I need a cross section of the boat. So I can come in with the box crop tool I can do a quick cross-section right through part of the ship. And I can just get a little sliver right where I need it to be. Now, this is going to be bigger than I actually need, but there we go. And this is how I generated the line right there. I actually looked on, basically set up a work plane and traced the edge of the ship right through that cluster of points right there. Now I'm going to turn the visibility of the point cloud off. And this could be, an example maybe I would do for the class or something like that. But I could come in and just real quickly do a surface patch based on the lines that I've created. And I can get a surface that would represent the bottom hull of the ship. And I could do a loft from this edge to this edge for the second part of the ship. Whatever the workflow is that you need, we can help you with. Now, it's not perfect. Remember, the boat's not going to be perfect, but the way we developed it, for as fast as we just went through and did that, looks really, really good. Could really easily be the beginning of the project of doing the entire boat. And I have finished, not finished it. I went a lot further than this. Here's the model that I have so far. I haven't worked on it in a while, but there's the model of the coaster. There's the entire hull and the main salon and the upper deck and the pilot house. And the cloud is still here. You can see how far I got with that. I would say you're looking at about 8 to 12 hours worth of modeling right there based on, finding pieces of the cloud, developing the line work, getting that done. So about 8 to 12 hours is where I'm at right now on this particular model. Now, there's other things we can do with point clouds. There's tons of things we can do. Maybe making the model is not what you're after. Maybe you just need to document your design. I need to take reality, get it into a tool like AutoCAD, and then start annotating it and drawing it and slicing it and things of that nature. Well, in our class, we cover AutoCAD as well. So for this example, I'm just going to hop into AutoCAD, start a mechanical template. On the Insert tab, we would talk about, attaching the cloud. AutoCAD has a little bit different method as far as, setting up the insertion point. So there's my boat dropped in at 0, 0, just like it was in Inventor. In the class, we would talk about aligning it. So drawing a line, we'd have to come in and draw a line to align the boat on the x-axis, draw a line for the z. We're not going to do that here. But in the class, we would talk about, the basics of point clouds in AutoCAD. Things like, the section plane, for instance. So if I were to come in and turn on the top section plane, I could select that plane and I could Take that plane and bring it down, you know, maybe into the hull a little bit. There we go. I'm just going to stick that work plane on a layer so I can turn it off. One of the nice things AutoCAD can do now, Inventor can't do this, but AutoCAD can. If I go to Paperspace in AutoCAD, I can set up a viewport to show the point cloud. So point clouds are visible in Paperspace. You can include those. And then at any given time, I can come in and, I don't know, let's see, let's add a leader, for instance. And if I were to do a plot preview, you would actually see the point cloud along with, you know, the title block and the annotations that I have. If I did a top view and added dimensions to that, or I did cross-sectional views of reality. I've got a couple of customers that when it comes to drawing clouds, they don't trace it. They'll slice the cloud and just put that on an AutoCAD sheet and just use the points themselves instead of drawing lines. So it's just one of the workflows that's available. Let me hop into Navisworks for a minute. We talk about Navisworks in the class. I know a lot of my customers haven't even used Navisworks. But I think Navisworks is really important. If you're going to deal with point clouds and with 3D models, you're going to want to see them both at the same time. And Navisworks is really the solution for that. I set this one up earlier today, so you know, I knew we wouldn't have time to build all this, but here in Navisworks, here's the point cloud, and I went out and got a Jeep Wrangler. I don't know if it's an 88 Jeep Wrangler or not, or I'm sorry, I don't know if it's a 70s era Jeep Wrangler. I think it's not. But I also brought the skiff in, and Navisworks allows me to deal with the cloud and solid data at the same time. So as an example, I could click the Wrangler, and there's move tools, so I can move the Wrangler up and get it set up onto the front deck of the boat. And I can do the same thing with the skiff. Make sure I'm looking at this correctly. Now, Navisworks has a way to do interference detection between solid data and point cloud data. It's actually a clearance analysis. So if you were to ask me what's the clearance the Jeep has to the hull, I could give that to you based on the Navisworks functionality. It's also a great visualization tool. Lets me see things like that full-scale Jeep in context of the laser scan of the boat. In Navisworks, I can also append a ton of different things. Navisworks allows me to deal with just about any kind of data you can imagine as 3D, any 3D data. Here's the recap stuff. That's what I'm going to use in a minute. But, you know, I've got CATIA data, Autodesk DWF, Faro, FBX, 3D Studio, Rhino, Pro E, all of this stuff I can bring in and put inside of, or put in context of a cloud. So let me see if I can bring in some AutoCAD data here. So here is that old red truck that I saw at the marina. Now remember, that's a scan of a truck. And my question is that going to fit up on the deck where the Jeep is? So I'm going to hide that. I'm going to hide the skiff for right now. And I can select the truck. I can use the item tools. You have like a revolving tool or a rotating tool. Let me make sure I turn on my snapping. That allows me to snap at 90 degrees. And I can bring the scan of the truck forward. I'll bring it up a little bit. Now, I've got just barely enough room to fit the scan of the truck into the scan of the boat. So if you're taking, if you're trying to do spatial analysis, maybe you're buying a new piece of equipment and you've got to get that through your shop to its new location, you could scan the shop, go scan the new piece of equipment, and make sure that the thing can actually pass through the doors and be lifted into position without fouling anything like the columns of the building or existing components that might have to be removed in order to install a new piece of equipment. Building scans like this, hybrid scans, is a great benefit of the Navisworks tool. And if you bear with me, I'll just finish up, let's see. So here is an entire ship deck. So this is a very, very large model. It's one of the larger models I've ever put together myself. I've already mentioned, all the different file types that you can read into Navisworks. These are just a few of them. CATIA, Pro-E, even SketchUp, like Google SketchUp or Trimble SketchUp now, I think. But I wanted to go back aft here. And one of the scenarios I had set up here was the scan of a pipe run. So I took the scan of a pipe run from either one ship or maybe another place on this particular ship. I got that into position. So here's the water plant area with just the point clouds in place. Then I was able to basically make the models. I did this all in Inventor. I used the pipe routing tools inside of Inventor to basically trace the pipe runs with Inventor's piping components. There's both of them together. And then here is inside of Navisworks, a full-scale character going through and looking at the data. Again, remember that you can do clash detections between clouds and existing solid data. So if you've got an existing design, you're trying to make sure it fits in context of a new digital design, Navisworks is a great tool to rely on. So listen, I've taken up the entire hour. I hope you've seen how we can take scan data, bring it into Inventor, start a new model. We can bring it into AutoCAD, start new documentation. We can bring it into Navisworks and compare it to other scans or other 3D files. And we're just getting started. Again, the class that I'm talking about is a 2-day class, and Again, once we go through it one time, then we want to rinse and repeat and do this as often as possible while we're together. It does take a little bit of practice, but once you have it, this process is repeatable and I think very reliable. So I appreciate you guys taking the time and being with me today, and I guess at this point we'll open it up to see if we had any questions.